Hello everyone, welcome to the second part of session 20 video, time series decomposition. So here's the brief agenda for time series decomposition. We're going to spend most of the time to going through the decomposition process. You should know the manual process, how to calculate seasonal factors, seasonal indices, and cyclical factors. So in terms of learning objectives, you should be able to calculate seasonal factors, seasonal indices, cycle factors for a given time series, and from here you should be able to generate the final forecast by using these three components. Explain the difference between seasonal factor and seasonal indices. So we'll go through that as we work through our example. So time series decomposition is one of the commonly used and one of the important methods when it comes to forecasting, and you should know how to create the seasonal indices and cycle factors based on a given time series. So seasonal indices will allow you to understand when there are shorter term fluctuations, and cyclic factor will allow you to understand when the economy is expanding or when there's a recession, right? So that kind of highlights the importance of seasonal indices and cycle factors. There are two different models to work with the forecast. Very first model is multiplicative model. For the multiplicative model, the final forecast is product of time series components that we will determine using given data set. Additive models, in this case, is the sum of different components, time series components. So time series components such as trend, cycle, seasonality, and irregular variation. Multiplicative, the product model, is used widely in industry because most of your time series are going to have some seasonal variation which increases over time. The seasonal variations are not constant from year to year. If that is the case, you're going to use the multiplicative model. So for our example, we're going to walk through multiplicative model. So here's what we said. The multiplicative model, the final forecast Y is the product of trend component, seasonal component, cycle component, irregular variation. In this chapter, we're going to calculate these three: trend, seasonal, and cycle component. And for the irregular variation, if it's not given, we are going to insert it as 1. So you're going to assume there's no irregular variation. Otherwise, I will give you the values. It's the only case when it's not given. So here, explanation about these components. So I will not go through these. So before we look into this plot, let's go to the data set. Why the plot is important, especially in time series decomposition case, because we want to understand if your time series exhibits seasonality, trend, and it has some cycle component. So you have this data set, which is session 20 time series decomposition chapter 6 data set, and our data is organized by quarters, right, on quarterly basis. Feb is first quarter, May second quarter, August third quarter, November is the fourth quarter, right? So that goes on from year to year. And column C, we have private houses sales, which is given in thousands of units. So again, quarterly sales. I will come later to the time index because the time index is required when it comes to the trend regression. The very first thing we do is let's plot. So let's plot our data set. I'm going to insert a line chart. We don't need the time index, so I'm going to remove that. So if we expand this line chart, one thing you can easily tell is that it has some short-term variations which are representing seasonality. So there's one cycle here. Similarly, you can say there's one cycle here. But cyclical components are difficult to detect and they are not visible when you have seasonal and irregular variations. So for that, we're going to remove the seasonal components first. The other way to confirm the seasonality and trend is if we do the autocorrelation. So again, let's use the forecast X for the autocorrelation. So I have my data organized in columns, quarterly, set seasonality to 1. Then I'm going to go on analyze. So under the analyze, we're going to look into private housing sales. So from here we can easily say this data exhibits trend because when we go from lag 1 to lag 2 or 3, it is not dropping to 0. It is quarterly data for lag 1, lag 4, lag 8, lag 12. All these bars are beyond 95% confidence level, so which means these correlations are statistically significant. X is very high autocorrelation on lag 1, 4, 8 and 12. Okay, so from here we can conclude that a given data set exhibits both seasonal as well as trend component. Okay, so from here we're going to walk through the process of time series decomposition. Very first thing we do in time series decomposition is we remove the short-term fluctuations, or we remove what we call the seasonality from our data set. If you remember from moving average chapter, when you take a moving average for a given time series, you remove the short-term variation. But the question is, how many periods should we use? So in your exam, I will not give you guys the periods. You need to look at the data set and determine how many periods are required. So if it's quarterly data, you're going to have 4 periods as part of your moving average, and monthly data is going to be 12 points moving average. It's weekly data, 52 points moving average, and so on. So once you determined the number of periods which are required for your moving average, the next thing we're going to check if we can do a centered moving average or not. So you're going to run into a problem when you have even number of periods. So whenever you have even number of periods, you're not going to have a true center. For example, for our quarterly data, we have 4 quarters in first year. So our center is really 2.5, which is representing the middle point, which is dividing your entire data set into 2 equal parts. But we don't have any quarter which is represented by 2.5. We have quarter 1, 2, 3, and 4. So when you're taking a centered moving average, in order to deal with even number of data points, we will start with 4 points moving average for quarterly data, but 4-point moving average will be listed at quarter 3. So let's do this first as a additional step to a centered moving average. So here's our data set, which is quarterly data. So I have column D, which is private housing sales, MA4, moving average 4. So why moving average 4? Because it's quarterly data. We don't have a true center. So I'm going to go to time index 3 or the quarter 3. And here we're going to take a average of first year. And now we're going to apply this formula across all the cells in column D. So that will give you 4 points moving average. But at this point, the moving average is not centered yet, right? Because we don't have a true center here. We have even number of data points, right? MA4. So in order to achieve the centered moving average, we're going to do one more step. So the additional step is going to be, in order to take the center moving average, we're going to take 2 period moving average of the moving average we calculated in the previous step. So let's apply this. Okay, so this is what we have as MA4, so which we centered at period 3. Now we're going to apply CMA, centered moving average. So CMA is centered moving average. So this column name is private house sales centered moving average, which is going to average of 2 consecutive moving averages we have from previous step. So in this case, we're going to have average of D4, D5, right? So those are 2 consecutive periods. So centered moving average is obtained. So just a quick note what's happening here. When you're taking this MA4 moving average, at this point you have removed any seasonal variation from the data set, and further PHS, the private house sales centered moving average, removes any short-term fluctuations too, or the short-term variations as well. Now the step 2, once you have your centered moving average, let's get the seasonal factor. So the seasonal factor is simply a ratio of actual sales in this case, or the actual demand, divided by centered moving average. The most common mistake I have seen in exam and even in real life, sometimes students divide this simply by the moving average. So in our case, don't divide it by MA4, right? I want you to divide it by centered moving average, which is column E. So let's go back to Excel. So here's seasonal factor, SF, so which is the ratio between private houses sold and centered moving average. 4 divided by E4. And one problem you may have noticed that we have lost some information. So in this case, I have lost due to the moving average 3 data points, which is Feb 59, March 59, and the very last data point here, right? So that's kind of a problem where you lose some of the data points as you apply the moving averages. Let's get the seasonal factors. To have seasonal factors in place, right? Degree of seasonality is a measure of degree of seasonality. Okay. The next thing is to calculate seasonal indices. So the seasonal indices are average of all like seasons. So let's go back to the Excel document. So in order to understand this, I have created a very small table here. Unhide all the rows here. So we have 4 quarters: Feb, May, August, and November. Then we have 4 seasonal indices associated with it: S1 for February, S2 for May, S3 for August, and S4 for November. So the seasonal index for February is the average of all the seasonal factors that belongs to February or to season 1. Similarly, average of all these seasonal factors for May, average for all the seasonal factors for August and November, right? Okay, so why we do this? The problem here is if you look at these seasonal factors and you try to use it as such, you're going to have varying season factors going from one year to another. It's going to be very difficult to maintain the data. And also, it also is capturing some of the trend, which is either upwards or downwards. We only want to capture the seasonality within a given year, right? Because later on, we're going to come to the cyclical component. So we don't want to be capturing that twice. So we always do an additional step, which is normalization process. So I'll come to that. While we do that, well, let's look at the formula first. So the normalization is, or the normalized seasonal indices is, number of periods multiplied by the corresponding seasonal index divided by sum of all the seasonal indices. So let's go back to our Excel document. So we calculate the seasonal indices. As we have 4 seasons, your seasonal indices must add up to 4. We are using this formula here. So we have 4 seasons, and M2 is the corresponding seasonal index for February, and divided by 3.99, right? So sum of all the seasonal indices. After normalizing, we can see the sum of all the seasonal indices is 4. In case you have 12 seasonal indices, such as monthly data, then it must add up to 12. Let's say 7 seasonal indices, it must add up to 7, right? So let's use normalized seasonal indices to populate column G. Paste it as values. So from here, you can now deseasonalize data, right? So you have your raw data, which is in column C, and we have normalized seasonal indices. We already did this in one of the previous chapters, right? So deseasonalizing is ratio of actual divided by corresponding seasonal index. So here's a plot. We have PHS, which is houses sold, private houses sold, the blue line, which has some seasonal component, and then we have private houses sold with centered moving average. And you can see when we have the centered moving average, this line is more smooth. The short term fluctuations are removed, or the seasonality is removed. Now the cycle component is clearly evident from here. So this is the process we went through up to this point. If you have even number of data points, we're going to take a moving average, we're going to center it using the additional step. From here we calculate a seasonal factor, then seasonal index, then normalized seasonal index. For odd number of periods, you don't need the additional step that we have here. You simply take the moving average, seasonal factor, seasonal index, and normalize seasonal indices. Okay, so once the seasonality is removed, then we can now start estimating the longer term trend. One important note here: when you're estimating the longer term trend, you must use deseasonalized time series. Don't use the original data set. So which means in order to generate a linear trend equation, we are going to use private houses sold centered moving average. So what I would like you guys to do, apply the linear trend using regression analysis, where your y values are going to be column E, then x values are going to be column B. So that will give you the linear trend equation, that what we have here, right? So from here we can see the intercept value 266.293, which is A, and slope is 0.093. So your final equation is going to be 266.293 minus 0.093 into time, right? So multiplied by time. Okay, so let's use our trend equation in order to get the trend component. So I'm going to go back to Excel, and we're going to put this side by side so that we can use the right equation. So for this we are working in column H. This is private houses sold, centered moving average trend. So the equation for the trend component is 266.293 minus 0.093 multiply by the time index. So that's why we use time index. So let's apply this across. So from here we have the center moving average trend component for private houses sold, and this is just to emphasize what we did here. So this is a downward trend. Plot the trend line using the private houses sold center moving average data set. Okay, so from here we can get the cycle factor. So cycle factor is a ratio between centered moving average divided by centered moving average trend. So let's go back to X. So we have a centered moving average in column E and centered moving average trend in column H. So this is the ratio between centered moving average for private houses sold divided by centered moving average trend for private houses sold, so which is 1.14 for August 1959. So let's apply this across. So now from here we got our CF. So for any period where the cycle factor is greater than 1, it is the expansion. Less than 1 is a recession, right? Okay. But again, we are working with the deseasonalized data, right? So all those values are derived based on deseasonalized data. Okay, so the final remarks before we generate the forecast. So we have identified different components that belongs to a time series. So I have seasonal and normalized seasonal index, which is the seasonal component. We have trend forecast here, and we have cyclical factor. So now we should be able to use these to generate our final forecast. So the final forecast is going to be product of CMAT, which is centered moving average trend, multiplied by seasonal index, multiplied by CF, which is cycle factor, and irregular variation I. So as I said earlier, if irregular variation is not given for your exam, you're going to use it 1. Otherwise, in real life, you may have some understanding if there's a shorter term variation So you want to induce that into your model, right? So again, anything less than 1 is going to have a damping effect, which means reducing the demand. Anything greater than 1 for the irregular variation is going to amplify demand due to random fluctuations. Okay, so let's generate the final forecast. I'm going to go back to Excel again. So I'm going to call column J, or let's give it more meaningful name. So forecast Y is product of trend component for our time series final forecast. So this is the product of trend component, which is H4 multiplied by normalized seasonal index G4, then cyclical factor I4, and the irregular variation is 1 in our case. So for August 1959, my final forecast is 336.46. Let's change it to two numbers and let's apply this across. So here's our final forecast in column G. So we only can predict up to May 2016 because we don't have enough data to create centered moving average for last 2 periods, right? So that's kind of a big problem with this, what I said earlier, that you're going to lose some data points when it comes to creating the moving average and the time series decomposition. I will now go through the business cycle indicators, so please go through this theoretical concept, read through it, and if you have any questions, feel free to reach me out. For session 21, I will be uploading the healthcare data with some questions so that you can practice time series decomposition and centered moving average method, as well as the combining forecast, which we discussed in the previous video. If you have any questions, please feel free to reach me out via email. Thank you very much.